This is Damped Atari 8-bit podcast.
The reviewers refused to believe I could do it with such cheap material, equipment. They said it wasn't possible to do it.
This is Antic, the Atari 8-bit podcast. I'm Kevin Savitz. Michael McInerney was a professor in the physics department at Rose-Hulman Institute of Technology, where he wrote several journal articles about how to control experiments and gather data using Atari computers. The articles included Interfacing the Atari Microcomputer in the Science Laboratory, which appeared in the spring 1983 issue of Journal of Computers in Mathematics and Science Teaching, Gameport Physics Introductory Experiments in Linear Dynamics, which appeared in the spring 1984 issue, and Computer-Aided Experiments with the Damped Harmonic Oscillator, which appeared in the October 1985 issue of American Journal of Physics. This interview took place on May 21st, 2018.
My first job was working with the British Council, which is the British Cultural Embassy. But I was only on contract. And in the 1980s, there was a cutback in the British government. And as I was married to an American woman, I came to the United States. But I realized then that my degree, which is in theoretical physics, was not much use. So I took a degree by Correspondence College, the NTS College, in I can't remember the name of it even. Computer electronics, essentially. How computers work, how the microcomputers work. So that way I learned enough about how small computers work to be able to do physics experiments with them. And I used the Atari because it was the one where I could most easily get hold of the CPU without and completely isolate it. So I could just have the CPU act as a timer by itself. Mm-hmm. The computer would be off appeared to be off. It wasn't actually off. But all the other computers would interrupt the CPU. It was very difficult to stop them doing that.
Right, and the Atari had this mode where you could turn off the screen and stop the interruption of the CPU, and it would run a little faster.
I don't think that was a design feature. I think it was a design accident, but it was a happy one. Mm-hmm. And so it suited my needs at the time, particularly as I didn't have any money for buying external timers that would have interfaced into the computer by themselves. So the Atari itself could play both those roles. Both the data gathering, of course there had to be a sensor outside, but the data gathering and the timing. And that was just very convenient. It was a time when 5K of memory cost $70. So,
right.
And I'm just unbelievable today.
Do you remember how you originally discovered that computer and that it could do what you want? I mean, did you have one at home for playing Star Raiders, or did you see one in someone else's classroom perhaps?
Was Star Raiders invented back then? I don't know.
Yes, it was, but...
Oh, I used to play World War II.
World War II.
There was a battle game in which you played on the German side trying to destroy the Russians. Anyway, it was on the Atari, but that wasn't why I got the Atari. Why did I get it? I can't remember. It might be because it was not too expensive, but quite good computer at the time.
Sure.
But and that's why I got it.
So you describe some experiments in these articles. One about testing, doing a basic experiment testing gravity the speed at which things fall, and you talked about doing things with phototransistors. And can you talk about specifically some of the things that you did? I'm curious, was this more of a theoretical teaching kids, or was it like we're actually doing science?
No. We implemented this into when I moved to Rose-Hulman, because initially I was at Eastern Illinois University. But then in 1983, I moved to Rose-Hulman, and we implemented in the introductory laboratories a simple timing experiment using the Atari, where we would, have an on-off event thing with air cuts, so you could measure speed and acceleration. We did those experiments for a couple of years, but it required the students to do some programming, and that was really too much for them. So after a while, when cheaper sensors became available, we moved to those. Plus, the school developed a policy that every student had to have a laptop computer, and Atari was not one of the recommended ones. So
that was probably a wise choice on the school's part.
Yes. So we moved away from them.
Sure.
I did, but we did simple time of flight. I also published a couple of papers in the American Journal of Physics. One paper in the American Journal of Physics on pendulum motion, where you get a golf ball and you find its speed, its maximum speed. If you know the angle from which it's dropped, mm-hmm. and you find the maximum speed that it's going at the bottom by an interval timer. The golf ball goes through, and it measures the time it takes to go through at the bottom of the swing, where it's essentially going constant speed. And you can track that against time. You can solve various equations. You can work out the air resistance on the ball, which I found quite interesting, and I delved probably way too deeply into it. It did teach me that the dimples on golf balls do not reduce the air resistance. In fact, they increase it, which is no surprise if you think for a tiny minute. Roughing out the surface is not going to make it smoother.
Sure.
What they do is they entrain the air and give it better directional quality, and they also give it some lift apparently, so that it can go further because it acts like it's not a wing, but effectively like a wing.
A little bit of Bernoulli effect.
It can fly. Yeah. It's a surprise. I was surprised to discover that. But that was interesting. And some of the theory that was done with much more complicated wind tunnels, I showed to be not completely correct. But, these things vanish without trace.
Did that article about pendulum motion also involve the Atari, or was that more general?
No, it was done with the Atari.
Oh, nice. I have not seen that one. I'll have to try to find it.
Yeah, it was a long time ago.
Yeah, I found 2 articles, and then you referenced, I believe, 2 other articles that said that you wrote that were unpublished, and I was wondering if you also had those. They all have very similar names, but I wrote them all down if that helps anything.
What were they called?
The unpublished ones are called Gameport Interfacing with the Atari Microcomputer, 1982, and another one, Gameport Output for the Atari 800-400, which was undated in the reference.
It sounds kind of likely that I wrote those. Well, obviously I did write them, otherwise I wouldn't have put it down. Okay, I have a copy of this experiment with the golf ball, and I'll give you its reference, okay?
Okay.
Interesting.
I'm ready.
American Journal of Physics,
mm-hmm.
number 53, brackets 10, October 1985, beginning on page 991.
Okay.
And I did that with the Atari.
Great.
People didn't believe that I could do that. Some of the reviewers said that I couldn't do it with such cheap equipment. But that wasn't the case. It was possible to do. It required a little bit of skill, but otherwise the results fitted in with most of the rest of the predictions. So I thought it was quite good.
Nice. So you said it required some skill. What was tricky about it? I assume you had to build some hardware yourself to interface with the joystick ports.
I just had to build I just built a pendulum using nylon fishing line because it's actually a very uniform diameter and you can vary the diameters. So actually I was able to vary the diameters of the fishing line and in that way remove the effect of air resistance on the fishing line so as to get it only on the ball. The difficult part about it was to release the ball without it wobbling in flight. Because if it wobbled through the timer, it would give an erroneous result. So you had to let it go without wobbling. Now, people suggested that I should build electronic release equipment, but that didn't work very well at all because the electronic release actually shook more than people's hands. So I abandoned that. But the reviewers refused to believe I could do it with such cheap material, equipment.
When you say reviewers, you mean because it was like a peer-reviewed article?
Well, yeah, I wrote another one for the American Journal of Physics, which extended what I wrote the first time, and they wouldn't accept it for that reason. They said it wasn't possible to do it.
Wow.
Which, I can understand that, and we're at a time now of kind of similar revolution in equipment. Equipment for physics experiments is now very cheap. So you can get good equipment very cheaply, and once again, people in large laboratories will be not believing that.
Sure, they think they need their specialized, expensive equipment to do the job. That's what makes them special, right?
That's right. Yeah, well, of course.
Cool. So, what haven't I asked you about that time that I should have?
I have no idea.
Okay.
I'm really rather surprised that anybody is interested in the Atari from all those years ago. I mean, it was a great little computer, but it was not followed up. I don't know why. Do you know why? It was it didn't become an IBM compatible.
Oh, there are many theories and reasons about that, but basically, Atari became a bloated and inept company that kept changing owners and made some wrong guesses. Yeah,
they fell for the human trap of wanting to keep their own product separate from everybody else's.
Yeah.
So that's a common psychological problem. But you can see that it doesn't work because retailers tend to build the same kind of store next to each other. And I assume they do that because they make more money that way. Like you get electronic stores clustered in one area of town.
Sure.
So forth.
Yeah. Tell me about what you do today. What are you working on now? What's interesting?
Well, I've just become a kind of teacher now in Rose-Hulman. My own interests. I went through a period of teaching computer-assisted physics, but then I stopped doing it because there didn't seem to be anything that was very special about it. all of physics became computer-assisted. It wasn't impossible to do anything without a computer. So, and then the techniques of solving equations in a computer were taught in the math department. So, didn't seem to me to be much point in going on with that. So I stopped doing that, and then I mean, if you're interested in what I'm interested in, I'm interested in the view of reality. This makes me sound a bit like a crackpot, but I'm interested in to what extent reality is, or our view of reality is influenced by our own minds. The way you think, how does it influence what we perceive as physical laws? Now you think, well, that couldn't be the case. But when you say that we have a physical law, we're actually making a mathematical statement. We say there's a space, a vector space, in which the system we're interested in resides, and that it moves in a path in this vector space. That's a mathematical statement that has lots of consequences. But why do we make that statement? Because we think that way. And that's what we see. So our laws are a reflection of the way we think. Now, this explains why mathematics is so useful in physics, because mathematics also must, on a more abstract level, reflect the working of your mind. And as that's the way you've constructed physics, it's no surprise that mathematics applies to physics. Is this a useful idea, or does it have anything at all to say to the world? Who knows? But I found it very interesting. I studied neural networks as a result, and I teach that here because I wanted to see, exactly how our brains worked with this. Then I studied image processing because that has a huge amount of brain interfacing within it. What we see is a long way from the original data. So I found that interesting, and I teach image processing here as a result. But as to whether there's any great consequences of this, I don't know. I don't know.
Oh, that's very interesting.
It might have something to say with our notion of time, because time is kind of a problem in physics. In that time only moves in one direction, but to us. But everything else moves in, you can move backwards and forwards. And it's really rather strange that we can only move one direction in time when there doesn't seem to be any particular reason why it's special. I see that this idea of time is being influenced these days. I mean, it's because come under question. And many scientists, I shouldn't say other because I'm not one of them, many scientists are looking at this and wondering whether we my own opinion is that we're in jail. Whoever runs the universe has set the time and the speed of light for us so that we're stuck here on Earth.
Huh.
It's all right. There's no scientific proof for that.
I've read a couple of things recently that Elon Musk and a couple of rich crazy dudes think that we're all living in a virtual reality. What do you think?
Well, yeah, yes, but it's not useful. This is the problem of the nature of reality. Does reality exist? Well, who knows, right? But essentially, who knows? You can't do an experiment that I know of to prove it, to prove its existence. It's just that it's a lot more convenient to believe it, in that you can get on with your life. Otherwise, what would you do?
Right.
So to say we live in a virtual reality really doesn't say anything at all.
Well, you can't do anything about it if we do, right?
Well, Yeah, and how would we know that what we thought was the outside of the virtual reality actually isn't just more virtual reality?
Mm.
There's no way to answer that. So unless I could dream myself surrounded by beautiful girls somewhere, I'm going to have to assume that this is what we've got. There's not a virtual reality that I can construct. However, that's not to say that reality and the laws of physics are as we see them. We are creating patterns in the universe which reflect the patterns in our mind. And the universe could be quite chaotic. But it appears to be. I mean, there's no reason why it should follow these laws. And you could argue that if it didn't follow the laws, we wouldn't exist to look at them. Well, that's probably true. So, once again, can we get anywhere with this? I don't know.
Awesome.
Anyway, that's interesting.
Thank you. I think I have what I need. Thank you.
All right. Well, it's been a pleasure and very flattering for you to call me up.
If you enjoy these interviews and would like to contribute, there are two ways you can help. You can help fund these interviews directly by contributing to my Patreon. A small monthly contribution will help offset the expenses of making these oral history interviews. Contribute at patreon.com/Savitz. Or make a tax-deductible contribution to the Internet Archive, a nonprofit digital library that has done incredible things to preserve computer history. Make your tax-deductible contribution at archive.org/donate. Thanks.